All right, we ended the last video clip in this lecture on simulation. So we've mentioned survey, observation, experiment, and then simulation is the last broad category of primary sources of collecting data. And a simulation, this is something that we don't see too often in anesthesia. I had to actually kind of search for an example that you can see there on the right side of the screen. And so this is where we're not actually doing anything. We're essentially using computers to simulate some sort of condition or process. And this is where using that computer will allow the investigator to study a situation that is impractical or even difficult or impossible to study in real life. Oftentimes this can save time and money. For example, you might be interested in if we change flight patterns on airplanes, what effect that has on airplane accidents. Well, we can't really do that ethically, can we? But we can certainly simulate something like that, and I imagine the airlines have done that. And you can see here this example, it was a pharmacokinetics neural mass model for the simulation of EEG activity during propofol anesthesia. That's a lot to say, but it is an example that as I searched for this lecture, I did find. So if you want to go look at it to get an example, just go on PubMed and type that in. You can see an example of a study that used simulation for collecting the data. So what is the best way to collect your data? It really depends on your research question. And there's a number of ways to skin a cat depending on how you want to go about doing it. For example, do nurses always wash their hands between patients? One way you could do this is you could do an observational study where you're just observing them doing hand washing, like an example we had earlier. Another way that you could answer that question is through a survey design. And you could survey the nurses on, do you always wash your hands between patients? And you would use a Likert scale from 1 to never to 5, they always wash their hands. Now, which one of these methods do you think is more accurate? Surveying people's opinions or observing them? Well, the answer is right in front of you, which it would be observation. But sometimes we have to make decisions as researchers based on the feasibility of can we get it done? All right, here's some examples, and I think I already gave you the answer to the first question there. But consider these following statistical studies. Which method of data collection would you use and why? And I'm going to knock on wood here because you may or may not see questions like this later in this week's content. All right, so a study of changing flight patterns on the number of airplane accidents, or a study of the effect of perioperative beta blockade on administration of perioperative myocardial infarction, and what is the rate and factors associated with CRNA call shift fatigue. So take a chance, you can pause the video and think of your answers. You can write it down on a piece of paper and then resume the video when you're ready. All right, the first one, and I already gave you the answer, was a simulation because it would be impractical or unethical, certainly, to do that. Question number 2, what do you think the answer is? Well, an experiment would be the best way to study this because it would help determine causation and minimize any confounding variables that may impact the outcome. And the third question would be a survey because you want to obtain a large representative sample to describe this phenomenon of call shift fatigue. And in fact, you can read this paper in the ANA journal. All right, what data do you want to collect? We've talked about ways to collect data. Now we want to talk about what data you should collect. Well, like I said, it depends on your research question and design of the study. It's also going to be guided by the literature review and your understanding of the problem. So that's one of the reasons why when we're doing research is that we have to do we need to do a good review of the literature. Now, all of that literature may not end up in your published article, or it may be a very concise, to-the-point review, but you probably read tons and tons of articles just to get to that maybe single paragraph to help you understand the problem, because it can help you identify outcomes of interest. It can help you identify key demographic variables that you may want to measure, and it may help you identify potential confounding variables, which may be a confounder, may be related to either your independent or dependent variable, and it may interfere with your outcomes. So here's some definitions. Data, we already mentioned, is a set of values of qualitative and quantitative variables. It is measured, collected, and reported and analyzed. We can recode the data multiple different ways. For example, we may collect stop bang scores, and each individual in a database, an Excel file, each individual subject would have their own row. Your variables would be each variable would have its own column, and so maybe you have the stop bang score in column 1, and then maybe column 2 you recode that data so that it ranks them by OSA severity based on a score less than 3, 3 to 4, or greater than 5. A variable is a piece of information you collect, what I just talked about. And they vary, variables vary, because they can go from being high to low. They can follow what's called a normal or non-normal distribution, which we'll talk about later lectures. Or they may be what's called binary or categorical variables. A binary variable, maybe it's yes, no, they're male, female. And you can operationalize variables in multiple ways, like I just talked about with stop bang scores. Operationalization is the process of defining the measurement of some phenomenon that is not directly measurable. And then we can use an instrument, a scale, or a questionnaire to measure that variable. And one variable may be a PONV, yes, no, did they have PONV? And maybe PONV may be their number of risk factors for postoperative nausea and vomiting. Another way to kind of operationalize it. Well, I wouldn't operationalize yes, no, did they have it, but that's another variable that you could measure. Pain scores we can measure with a visual analog scale or a verbal numeric rating scale. Maybe you go into the medical records and the nurses record the 0 to 10 pain score in the record, and you write that number down. You could also then take that pain score and operationalize it as maybe none, low, medium, or high pain, or mild, moderate, severe, I should say. And we also talked about the example of a stop bang score. Data variables can be collected and they're further classified as either qualitative, or what you can think of categorical or non-numeric variables, or quantitative or numeric. Categorical variables, you break that down even further to nominal, which is where the data cannot be ranked in any order, like gender, ethnicity, anesthesia type. Neither one of those, you can't say that males are greater than females. Data that's ordinal, or it has some sort of order to it. For example, small, medium, or large hospitals would be an example of ordinal level data. The reason it's important to understand the difference between qualitative and quantitative variables is because these are linked to the type of statistical test that you would choose. And we'll talk about that later lectures. Quantitative is where it has some sort of numeric value to it. Did you count or measure the data? And these can be broken down into discrete or continuous. Discrete data is data that is counted and they have whole numbers. For example, number of siblings. You can't have 1.5 siblings. Number of surgeries that a patient had. A pain score would be a discrete variable. A continuous is measured on some sort of a scale. Classic example would be weight or BMI. you can see I do have a typo there. Number of surgeries had is a typo, and that was really falls under discrete data, so I apologize. Here's another example of measurements of variables. Um, you can have a nominal. Nominal I talked about, male, single or married is one example. Ordinal, where you might have a satisfaction scale which goes from not satisfied to very satisfied, and we may code that as a 1, 2, and 3 in our database so that we can actually do some statistical tests on those. An interval scale is another example of a continuous scale, and this is a classic example would be like a thermometer, whereas a ratio scale usually kind of goes from like a 0 to an infinity, meaning it could be never ending. In reality, weight would never end in patients. So you can see here different statistical methods are appropriate for variables at different scales. And you can see here with nominal is A different than B? And there's some examples. Ordinal is A bigger than B? An interval would be how many units do A and B differ by, say with temperature, SAT scores. A ratio level, how many times bigger than B is A? And you can see like distance, length, time until death, weight. SAT scores, or even MB-CRNA like C exam scores, that would be an interval level data. In reality, the difference between interval and ratio, in all practical purposes, the statistical tests we use are exactly the same for that type of data. And you can see there listing below are some operations that make sense for these different types of variables. You certainly can count all of them, but you can only rank ordinal, interval, ratio, add and subtract only interval and ratio, and you can only do multiplication and division with ratio level data. Another way to look at data is the order of values is described. I'm sorry, the order of values is known. So it can be ordinal, interval, or ratio. Counts or like the frequency distribution you can use, and so on. You can go through it. You can pause the video and look a little bit further at this this slide to help you understand it a little bit better. And you can see some different ways that we can calculate the mode, which is the most frequent. The median is the most common value in the middle. The mean is like the average. And then if we're looking at quantifying differences between values, that's where we're looking at continuous level data of either interval or ratio. And if it only has a true zero, that's a ratio level data. Here's just another example of differences between quantitative and qualitative variables or categorical variables. We're going to pause here, and then when you're ready, continue watching the next clip in this lecture series.